Hello, integrated science students. Welcome to your next CLEVR Poster assignment. This is another Pivot Interactives assignment. This assignment will be completed in Pivot Interactives. Once you have answered all of the questions on the Pivot site, you are finished. Your score will automatically be transferred into Canvas once your teacher has completed the required grading on the Pivot site. So you're going to open this the same way you opened assignment 4.3 and 5.5 by clicking the link at the bottom of the instruction page, which will take you to a new tab. You will log in with Google. And your assignment will look like this. This time, we're going to explore a different relationship. We are going to explore the relationship between increasing mass of the sun and resulting orbital period of a planet. Now, orbital period is a fancy word for the time it takes a planet to go around the sun once or 1 year. So every time that a planet goes around the sun and comes back to the point it started at, that's 1 year. The first step in this is going to be identifying the variables. So you can launch the simulation and explore on your own. You can adjust the star mass, make it bigger or smaller, and you can play around with mass of the planet if you want to. If you want to reset your simulation, you use the orange button at the bottom. And once you've played the simulation a few times, it does help if you turn the path and the grid on. That way you can see where you started and where it ends. Once you play the simulation a few times and take note of the number of Earth days down here, you can start to answer these variable questions. So the first one is, what is the independent variable? The variable that we're going to change. Now remember, on these variable questions, I give you 3 out of 3 submissions. So you should be able to get this question right. And I do want you to know this information before you move on. So the thing that you're going to change in this experiment, you can change a lot of things using these boxes. You're going to be changing the mass of the sun. When you submit your answer, it will tell you if it was correct or not and how many submissions are remaining. Once you answer all of these questions, you will move on to the next section. For this one, I want you to select a hypothesis. So before you select your hypothesis, follow the instructions in this announcement. So you're going to launch the simulation and adjust the settings until they match the images below. So make sure that it's just the sun and Earth. Make sure that the path and grid are turned on and that our sun is set, the star mass is set to our sun and the planet mass is set to Earth. Okay, so and also note the distance that the Earth is from the sun. You can move this guy all around on the grid, but you want to make sure that it is right there every time that you start the simulation. Now, use the play button to begin the simulation and pause it once the Earth returns to the starting point. So it will look just like that. It's kind of tricky, so you got to pay attention. And I'm going to stop it right there. Oh, I made it a little far, but that's okay. Note the number of Earth days that have been recorded on the bottom right. So I recorded 368. So I'm just going to remember that. Now, adjust the mass of the sun and run the simulation again. So you could make the mass of the sun smaller. I'm going to reset my simulation before I do that. Make the mass smaller. And now with this smaller size, I will run the simulation again. And again, I will pause it right when it returns to where it started and note the number of Earth days in the bottom. Looks like you can zoom out if you need to. Whoa. Let's run this on fast mode. Oh. Well, silly me. It looks like the Earth is missing now. Okay, never mind. Okay, I'm going to adjust the mass of the sun to be a little bit bigger. And I'm going to run the simulation again. And this time I'm going to note the number of Earth days on the bottom right at the point when the Earth returns to its starting point. Okay, 246 Earth days. And that one is maybe a little bit early. Okay, now that you've looked at comparing those two variables, so there's lots of tests you can run with this simulation, but we're comparing star mass and Earth days, or star mass and orbital period. You're going to select which hypothesis you think is correct. And once you select that, you can submit your answer and move on to the evidence section. Now this one's going to be fun. We're going to launch the simulation, and the settings are going to be the same as what we were just playing with above, but this time I'm going to ask you to follow these specific instructions. So use the play button to begin the simulation and pause it once the Earth returns to the starting point. We've already played with that. Record the number of Earth days in the data table below. Okay, so we found that, what was our number above? I think it was 368. We found that when the mass of the sun is 1.0 times itself, there were 368 days in the orbital period. Okay, then reset the simulation and adjust the mass of the sun to 1.25. So we're going to slide this right between 1 and 1.5 and run the simulation again, which we've just done above. And you can see that it was 246 Earth days. So in our data table, we're going to write mass of the sun, 1.25. And the orbital period was 246 Earth days. Now, so that's step 4, record the number of Earth days in the data table. Now, what I want you to do is repeat steps 1 through 4 until you have a total of 5 data points. So I want all of this table filled out. And then as you fill out the table, this has an associated graph. So this graph is set up for you this time, and moving forward, you might be asked to add some of the things that are already added. So you can see that we have orbital period on our vertical axis because the number of days, that is our dependent variable. The dependent variable always goes on the y-axis, and then we have mass of sun on the x-axis. And so every time you enter a data point in this table, it will populate on this graph. A complete graph has labeled axes, it has numbers on each axis, and it has a title. So this one will populate as you enter your data, and then once you finish all 5 data points, you should have some evidence to support your claim. Using this evidence, you can select the correct claim below. So our driving question has been, what is the relationship between increasing mass of the sun and the resulting orbital period of a planet? Now that you've made observations about the relationship between mass of the sun and orbital period, you are ready to make a claim. You're going to select the correct claim and you will be finished. Good luck.